Hello everyone, I am Vidit Manyar and I am going to demonstrate our Compi Tuner 2 project on behalf of team number 3. Here's the team roster. The team member composition is something like this. We have Chandni Shah, Karmik Patel, Chinali Chaveri, Ishant Soni, myself Vidit Manyar and Henel Shah. So our project is Shaktiman, the green food game. For an introduction, Shaktiman is the classic Indian yogic superhero who is obviously the hero of the game and is going to fight Kazaki, the robot sent by the supervillain to destroy the city of Andaman. Well, that is an abstract story background for the game. Now jumping into the implementation part, all these team members have implemented one design pattern each and we shall go through each of them one by one. To have a start with, I'd like to mention Dharmik Patel for his contribution towards implementation of command pattern. Let's check that out with the game. Reset. Okay, so we needed to implement the command pattern since we are for the game menu which comes up during the start of the game. The command pattern is a behavioral design pattern in which an object is used to represent and encapsulate all the information needed to call a method at a later time, or in some cases many a times. So here we implemented the command pattern during the game menu which appears at the start. As I said, here are the two buttons, the play and the help button. They extend the button superclass. Let's go to the UML diagram and technical details. So the command pattern has an object of the invoker which gets the command from the button and transfers it to a receiver via the button command interface. Now this receiver class has the actual code that is to be executed. All the logic and implementation of the execution of command of either of the button play or button help, is in the receiver command. The same is case with every button. As I said, every button which is included in the command pattern follows this particular protocol. The logic is written in the receiver class and it is executed via the invoker when we click on either of the buttons which are extended by the button superclass, which again is in after. Now the next pattern I would like to mention is done by Ishant Soni, which is the factory pattern. Now when I hit the play button during the game scenario requires to generate one out of the three type of enemies randomly. I'd like to pause it a bit here. Yeah. So there are three kind of enemies, as I said. The three enemies are fighter, colonel and captain. So the three enemies, one out of three enemy has to be generated by the game scenario. The factory is with the creational pattern that we have implemented in order to get this done. Let's go and check the technical details. So here it is. So as I said, there are three kind of enemies: the fighter, the colonel and the captain, and hence we have got three respective factories for them: the captain factory, the colonel factory and the fighter factory. The fighter factory is responsible for generating only one kind of enemy, that is the fighter enemy, and so is the case with colonel and captain. These three factories, they extend the enemy factory which has the responsibility of creating randomized enemy one at a time. And every enemy is generated at a time difference of 1.5 seconds. So the enemy factory randomly chooses one out of these three factories in order to generate one of the respective enemies. So in this manner we have implemented the factory pattern. The next on the list is the observer pattern, which is implemented by Henel Shah. Now since this is a game, we needed to implement the observer pattern in order to check the points which are scored by the player during the gameplay. So let's get started and see how it works. So as I go through the game, there will be a random generation of enemy which will come and try to attack me. Here it is. When I attack it, I get 12 points for hitting that enemy. So this has been implemented in our game using the observer pattern. So let's check the technical details. Here it is. That's the UML diagram for the observer pattern. Now, since we have only one subject, one observer to which the score entity is related, we will have only one subject. The game point class is the observer which is attached to the Shaktiman subject. So now whenever there is a change in the score, whenever the Shaktiman kills either of the three enemies which come across its path, the observer, that is the game point class, will be notified. Now this all is encapsulated using interfaces. So this is how we have implemented the observer pattern, and it is really handy in such a situation. Next on the list I see is the iterator pattern, which is implemented by Jinali Javeri. So now, why do we need iterator pattern? I would like to demonstrate a little bit with the game. I'll continue with the game, and when I kill an enemy, you see that there is a slight animation which is implemented during the explosion. As you see here, yes, at the moment you hit anything, that there will be an animation. So this thing, for implementing this thing, we needed iterator pattern. Let's go to the UML diagram. Yes, there it is. That's the UML diagram for iterator pattern. Whenever Shaktiman shoots any enemy with bullets, enemies are killed and explosion occurs. Now, to generate the animation effect, iterator pattern has been implemented, as I already told you. 3 images are used to construct this animation, and these images are circulated in a loop. Explosion class acts as the client, and the method show explosion creates explosion on the screen. Image iterator IMPL will be used to traverse. This class is used to traverse the list of images, and image repository IMPL stores the images and provides method for returning the iterator instance. So this is how we have implemented the iterator pattern in order to show the explosion. Moving on to the next pattern that is implemented. On this we have state pattern that is implemented by Chanisha. Now I would like to mention here that the shots that the game character, the game hero possesses, the Shaktiman, are limited. They are limited to certain number, and as we use them, they will start decreasing. Let's move further with the game. So as you see, the shots are decreasing as I fire them. There will be a time when I'll be out of the shot state. My shots, I no longer have them, and even though I try so much, I cannot fire any of the shots. And here is the blue colored bonus. This is for the bonus of, oops, I lost. I'll reset. I'll count again. Okay, so as I was saying, initially we allow player with 30 shots, and if they use it just like the way I am, that is they wasted, they will soon run out of shots. Now the shots are 0. Now here the shots, Shaktiman goes from hash shots to the no shot state, and that is the time when we need something to occur. What is happening is there appears a blue colored bonus which grants me 10 extra shots, and for the game to continue. Again, I am out of shots, I'll take the blue bonus. Now it switches the state from no shots to hash shots, and I can fire 10 shots at once. Okay, so let's get to the technical details, how it has been implemented. So that's the UML diagram for the state pattern with the code of 4. So there is the Shaktiman class, the Shaktiman state interface stores the information with via the implemented has shot and out of shot state. So as I said, as soon as the Shaktiman character is out of shot, the shots are switched, and vice versa. This pattern is applied to keep the state of Shaktiman. I mean, as I said, out of shots and hash shots are important from the view of putting in the bonuses at the right time. So this is where and how the state pattern is implemented. The last one on the list is the strategy pattern. Now, as I've already said, there are 3 kinds of villains, and out of them, 2 type of enemies in the gameplay: captain and the colonel, who fire shots towards the hero character. The captain fires the black bullet shot while the colonel fires the grey missile bomb. These attack types have similar motto, that is to attack the hero, but different behaviors, and hence they are implemented using a strategy pattern. Now I'd like to show you the humor diagram for the same. So that is the humor diagram for the strategy pattern. Since these are the only participants, we have not mentioned the third kind of enemy. So the captain and the colonel, they can use a short enemy and bomb enemy class objects respectively. But if during the gameplay in the further levels we need to change the nature of shots fired by the captain and colonel, that is, if we want the captain to fire the bomb instead of the shot, we can do it via the method change attack. This helps us to switch on the type of attacks made by both the type of enemies interchangeably at any moment in the game. So that is all for the demonstration as a part of implementation of design patterns for the project. Thank you so much for watching.